Welcome to our class on Henry's Law in soft drink production. Today, we'll explore how Henry's Law is applied in the manufacturing process of your favorite fizzy beverages. When you open a bottle of soda, that delightful fizz is created by dissolving carbon dioxide gas under high pressure into the liquid. But have you ever wondered how this process works? Let's understand something about solubility. Solubility refers to the ability of a substance to dissolve in a solvent to form a homogeneous mixture known as a solution. In the context of gases dissolving in liquids, solubility specifically refers to the maximum amount of gas that can dissolve in a given amount of liquid at a specific temperature and pressure. Solubility of gases in liquids is greatly affected by pressure and temperature. The solubility of gases increase with increase of pressure. Increase the pressure over the solution phase by compressing the gas to a smaller volume. This will increase the number of gaseous particles per unit volume over the solution and also the rate at which the gaseous particles are striking the surface of solution to enter it. The solubility of the gas will increase until a new equilibrium is reached, resulting in an increase in the pressure of a gas above the solution, and thus its solubility increases. Henry's law is a fundamental principle in chemistry that explains the behavior of gases dissolved in liquids. According to Henry's law, the concentration of a gas dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid. In simpler terms, when the pressure of a gas above a liquid increases, the amount of gas that can dissolve in the liquid also increases. In soft drink production, this means that to increase the solubility of carbon dioxide in the beverage, manufacturers seal the bottles under high pressure. As the bottles are sealed, the high pressure forces more carbon dioxide into the liquid, resulting in a highly carbonated soda. This phenomenon occurs because the high pressure above the liquid increases the partial pressure of carbon dioxide, causing more carbon dioxide molecules to dissolve in the soda according to Henry's law. When the bottle is opened and the pressure is released, the excess carbon dioxide comes out of solution in the form of bubbles, creating the characteristic fizz in soda. So, the next time you enjoy a refreshing soda and marvel at the fizzy bubbles, remember that it's all thanks to Henry's law at work, governing the solubility of gases in liquids. I hope you enjoyed learning about the science behind soda carbonation. Don't forget to like, share, and subscribe for more fascinating science content. Until next time, stay curious.